Okay, it is now 9:01, so what I would like to do is go ahead and thank everyone for attending the session this morning. Quick housekeeping items for attendees. Please note your lines are going to be muted by default during the presentation. We will be addressing questions at the end of the session, as we do have a fair amount of content to go through in about 30 minutes. At the same time, feel free to submit questions online as well at any point, and we will address those as well. My name is Brian Thomas, and on behalf of CED, Royal Wholesale, and CES, I want to thank you for attending this 7th session of ours, our monthly application webinar series. The topic we're discussing this morning is an application for Barry Callebaut, where they achieved an impressive return by investing in their systems to determine where manufacturing bottlenecks occurred and achieving real-time performance monitoring. This presentation is delivered by DST Controls, one of our preferred integration partners throughout California. At this point, the DST Controls team will introduce themselves, and we'll go ahead and get started.
Thanks, Brian. This is Lonnie Bowling with DST and
Reed Hayward with DST.
Thank you, everybody, for coming in this morning and joining us on this. We're excited to share some information with y'all. What I'm going to cover today is talking about what OEE is, which is overall equipment effectiveness, and I'll get into the definition of what that is and some details about what OEE, how OEE is calculated, and what it means for a plant that uses this metric. And then at the second half, I'm going to review the Barry Callebaut use case and talk about how they implemented OEE and what it did for their organization. So without further ado, we'll go ahead and jump right into it. I'll try to keep this as lighthearted as possible. It can be a little dry, and you might feel like you're back in your 8th grade math class at some point here, but we won't get too deep into it, just to warn you up front. All right, let me get my keyboard going here. Let's see. Okay. So let's just talk about high level what overall equipment effectiveness actually is and what we're trying to achieve with it. And I pulled this off of Wikipedia, and I thought it was a really good, simple kind of conceptually what it is we're trying to do. And every plant, every piece of equipment has some kind of potential performance that is inherent in it. And what we actually get out of that is some other performance, and it's never actually what your potential is. So what OEE is really just trying to do is just trying to measure that gap between what we're really getting out of our equipment versus what we should be potentially getting out of our equipment if everything was working perfectly. All right, so let's talk a little bit about why OEE and other metrics like OEE are important before we get into it. I think it's good just to kind of understand the ramifications of companies that employ lean manufacturing processes such as OEE. Typically, plants that do these types of have these kinds of measures in place versus plants that don't. There's a 10 to 50% improvement performance depending on what you're making and how new your plant is and other factors. But the bottom line is that if somebody is not using OEE or something similar to that doing some kind of performance monitoring and measuring, and they implement a system, even a simple system that we'll be talking about today, there's substantial savings that can be had right away. And so I think this is a really good driver for companies that are thinking about either going from a manual to an automated system or from no system to a very simple system. It doesn't have to be something that has to be too difficult to start with. So the other big thing that you get when you start measuring things is you can figure out where improvements should be made and what money you should be spending in what areas and how much money you should be spending. Maybe your line is at full capacity, and by measuring it, you actually demonstrate that it's at full capacity, and you need to spend money on new lines. Or maybe your line is not at full capacity, you need to spend some money on improving that. Those kinds of decisions you have to make when you have firm data, solid data that's standing behind you, And then once you put in those improvements, are they actually it just joined in on the phone. A lot of background noise here. All right, sounds like it went away. Great, thank you. So anyway, you know, where we're spending money versus you know, after you spend money and being able to see that, hey, you know, we actually achieved what we wanted, or maybe you didn't achieve what you wanted, and it'll give you more information to figure out what you need to do differently on the next round of spending. All right, so that's what OEE can deliver. Let's talk a little bit about actually what it is, and this is going to be very, very basic, and we're not going to get deep. OEE can get very complicated very quickly, but I just want to bring up the point here as we get into this that even the simplified high-level version of OEE that I'm going to present here, this is still very beneficial, even if this is all you start with. And hopefully you'll be able to tell that, hey, you know, this is actually something that we could do. So what are we talking about with OEE? OEE is broken into three metrics: availability, performance, and quality. And it's these three metrics are just multiplied together and to give you the high-level OEE number, and all of these are expressed in percentages. And I'll get into how they're calculated and what goes into each one of these. But a good example here is just maybe from, you know, a plant that thinks they're, you know, hey, we're doing pretty good. We're 77% available, performance 95, quality 92. Our overall OEE number is going to be multiplied, those three together, which would give us 67.3. Now, when I first saw OEE and I saw these calculations, the first thing that I thought was remarkable is, man, 67.3, that's kind of low. When I look at these three numbers, you know, it's not, you know, we're not up in the 80, 90% range for our OEE. We're actually at 67.3. So the first thing to realize is this isn't an average of the three. This is actually this multiplication. So if your availability drops to 50%, you're never going to have an OEE that's going to be above 50%. So, so that's just something to keep in mind as far as, you know, when you're looking at what an OEE number actually is and what you're trying to achieve. Some people can get kind of bummed out that the numbers are low, but, you know, my comment to that, if you are bummed out, that, hey, you know, there's a lot of opportunity there to improve and to save a lot of money. If you haven't been using it before, I mean, there's a great chance that you can make a big impact. All right, so let's just jump into this a little bit deeper and talk about how we get to those three metrics. There's really 5 things to go into it to do these calculations. So I'll talk about these 5 first of all, and then we'll talk about how the calculations happen. So the first concept is scheduled time. Scheduled time is really something that's what you think it is. It's going to be like that shift, you know, Monday through Friday, that day shift or that swing shift, Monday through Friday. It's just a set schedule of when you're supposed to be operating your equipment. If you're a plant, you run 24/7, well, your scheduled time is, you know, 24/7, every hour of every day of every week. So the scheduled time really is just when should we be running this equipment. The next item is the operating time, and that's a measurement of when did the equipment actually run during that scheduled time. And by running, we mean that, hey, you know, it's on and it's producing some kind of output that it's designed to do. So things like planned maintenance or downtime and things like that are going to reduce your operating time. If you have some kind of a fault or equipment malfunction or jam or something like that, that's going to reduce your operating time. So, you know, your operating time can never exceed whatever your scheduled time is, and often, you know, it's going to be somewhat less than what your scheduled time is. The ideal cycle time is the next item. The ideal cycle time is just talking about when our piece of equipment is producing whatever it is, that it's making whatever it's supposed to be making. What's the ideal cycle time that happens for each part? So, you know, if it's a bottling line and you're spitting out, you know, bottles every, you know, 10 bottles a second, you know, that's going to be 1/10 of a second would be your ideal cycle time. If you're doing something like, you know, some bagging operation, it takes 15 seconds to fill a bag, then that would be your ideal cycle time, and that's really just a static value. Now the parts produced is the other thing that we need to track, and that's just measuring those parts that are coming out of a machine, and we're just counting those. How many parts did we actually produce? And then the last thing that we're after is good parts. So out of those parts that were produced off of machine, how many of those were good parts? And so it's always just going to be a subset of those parts produced. So those are the 5 things. If you can get these 5 things, if you can start tracking these 5 things manually or automatically, then this is going to give you the ability to do accurate OEE calculations. All right, so let's talk about how those five components actually factor into the calculations of availability, performance, and quality. So availability is just simply your operating time divided by your scheduled time. So if you're scheduled to run 8 hours, you only run 6 hours, then it's going to be 6 hours, 6 divided by 8. That's going to be your availability, that percentage. Or if it's 4 hours, then it's 4 divided by 8, 50%. Your parts produced is probably maybe the most complicated out of everything here, and this is, your performance calculation is more complicated, but it really isn't all that difficult when you think about it. All we're trying to figure out is how many parts should we have actually produced over our operating time. So if we were, let's say we had a ideal cycle time of 1 minute and we operated for 60 minutes, then we should be able to produce 60 parts over an hour. And that's what that bottom half, the operating time divided by the ideal cycle time, is going to give us. So that would say, that would be 60 parts over that 1 hour. Now, do we actually produce 60 parts over that hour? Maybe we only produce 40 parts or 30 parts. If it was 30 parts divided by 60, that's going to give us a 50% performance. If we're at 60 parts, that would give us 100% performance. So performance is really just kind of about what did we produce versus what could have we have produced based off of that ideal cycle time. And your quality is pretty straightforward, I think. Just taking your good parts and dividing it by your parts produced, that's going to give you what your quality number is. So if everything that you made you're able to sell, then your quality number would be 100%. If you have any kind of scrap, bad parts, anything like that, that's going to reduce your quality percentage. So once again, we're just going to multiply these 3 together, and here's another example of some typical numbers that you might expect to see depending on your operation. And then if we multiply all those together, we get an OEE number of 47.2. So here you can see we're in the 70s and 80s, and our OEE ended up being all the way down at 47%. But just to give you a reference, world-class companies that live and die with OEE and have lean manufacturing, if you get into the 80 and 90s of OEE, you're doing remarkably well. So an honest OEE number that's above 50%, I think, is doing pretty good, and typically you'll see numbers below that. So just remember, this is a multiplication, not an average. All right, so what do you need to actually get started if you want to implement OEE? Well, we want to be able to try to collect this data in an automated fashion as much as possible. Sometimes that can be difficult, but it's worth it trying to do at least maybe some of the OEE calculations if you can't do them all. So the first thing that we want to do is we want to get that scheduled time, and that's really just going to be a manual entry into some kind of software that will usually you just set your schedule, you say this is what our normal schedule is, and then you go adjust it as needed if you have a holiday or you have to start early or you have training or something like that. You can go adjust your schedule. In the operating time, we usually tie into a machine or a line, and we're looking at the start and stop events off of that. And if there's anything that's in a machine that says, hey, if this motor is running or the solenoid's fired, then the machine is operating, that's something that we usually want to monitor automatically, and then we would record these operating start and stop times in an automatic way. It's usually pretty easy to get to. Ideal cycle time is just another entered value that is set and never changes for a particular machine with a certain product. Sometimes you'll see ideal cycle times vary if you have different products on a machine. One product is going to take longer than another product, so you'll load in a different ideal cycle time when you do a changeover or something like that. But really, it's just a single value is all we're looking at. And then the parts produced is usually not too difficult to figure out. Some sensor that will tell us every time that a part has been produced, maybe on the output of a line where you have your product running by and we have a counter with a sensor that usually takes care of the parts produced data collection. And the last thing is the good parts. If there's at some point in the at some point after the part is produced, if there's a inspection or something that is going to kick out bad parts, then we would like to produce anything that makes it past. We'd like to count anything that makes it past that point for our good points, or we could count the scrap. That would give us our bad parts, and then we could just take the parts produced minus the bad parts, and that would give us our good part count. So there's a couple of ways to get that. Sometimes this can be a challenge depending on you know, whether you're tracking scrap and bad parts. So even if that isn't happening right now, it's possible just to kind of manually enter this information at the end of the shift if somebody can go count up or weigh something or whatever it might be. All right, so once you decide, okay, these are the 5 things we're going to collect. What do we actually need to do to get a system in place? And this is once again just real high-level stuff, just to kind of give you an idea of what's involved. So the first thing you're going to need is some kind of software that's going to do your OEE data collection and calculations. We specialize at DST using factory talk metrics. It's a Rockwell product, and it will do all the things that we talked about earlier and a lot more. You need a server to install factory talk metrics on, or whatever other software that you're using, and that's going to be the central place where all the number crunching happens, the data is stored, and the reports are produced. Normally, we want to have a PLC that can monitor the equipment that we're interested in. You know, most modern manufacturing facilities, the machines are already being operated by PLCs, so we can add an additional purpose with that PLC just to do the monitoring and tie into those specific start-stop and running and a lot of other kinds of information that can be really valuable we can get out of that PLC. If the equipment isn't running off of a PLC, then we can always put in sensors and then hook that into some kind of a very inexpensive PLC and then have that go into metrics or whatever other software we're using. And of course, we need the server and the PLC to be able to communicate, so we need some kind of a network that needs to be put in place to allow that to happen. And you know, typically that's going to be some kind of an Ethernet network that will allow everything to talk to each other. And as an OEE system spreads throughout a plant, this network would also expand and go out to all the machines if the systems aren't already networked together. And then, of course, you're going to need somebody to help you with all of this. Just you know, whatever you might be doing in-house, you still probably want to have somebody get you going on it. So DST's here. We're really good at this stuff, and we're definitely would love to help anybody out that might be interested in it. That's just my shameless plug. All right. So let's jump into the last section here and just talk about what is the you know, our use case. We worked with Barry Calabote out at American Canyon at their American Canyon facility. They have 65 plants throughout the world. They're the largest chocolate producer in the world. I think they have 35% of the market. And at this particular plant, we worked very closely with the plant manager, and what they were after were trying to figure out where their bottlenecks were happening. And you know, and it wasn't kind of like the plant had been running for a long time and they weren't doing any improvements. They actually were doing a lot of improvements, and their bottlenecks were always kind of changing because of different products that they're trying to produce and different performance installations and improvements that they were doing. And so this was actually a challenge for them to figure out, you know, where should they be, where are things that need to be monitored and looked at more closely. They also wanted to see this real-time reporting. Real-time reporting they felt was going to be really valuable for them because they're going to be able to respond a lot more quickly to problems. And then they also had a problem with inventory and adjustments that needed to be made on recipes and batches. and that was just kind of a quality thing where they were measuring ingredients and mixing things together, but they really didn't have a good understanding of when their batches were not done correctly and what they were over and under, and they would see this kind of manifest itself in the inventory because they're ordering more or less of what they thought they actually needed to produce their product. They're producing a lot of product here, so this is a pretty big item for them. After Rockwell worked with them directly to get an OEE system up, DST went in and filled in the OEE system throughout their entire plant. And what you're seeing here is just a simple OEE report from Factory Top Metrics. It's just showing the OEE broken down by. Got somebody with a background noise there? If you have a phone, that'd be great. Thanks. Anyway, this is showing different lines, different pieces of equipment, and down to the shift and down to the product of what their OEE numbers are at over any given time. And that's just real time. They can pull that up any time, even as the shift is happening. The other thing that they were interested in, besides the OEE stuff, and this would be a typical next step, is to record event data. Event data is going to tell you when you do have a problem, what was the nature of that problem and what are the biggest problems we have with a particular piece of equipment. And so, that's always kind of, from an operational perspective, you're kind of looking at, how can we improve our OEE numbers? How can we improve our performance? And this event data, whether it's a fault or some kind of a door opening and closing, hundreds of times during the day that stops the machine, those events can kind of key you in as to, where you could focus to really improve your performance. And sometimes the events come up, they change over time. So just because you're not having a problem today, it doesn't mean that you won't have it tomorrow. They also used metrics to measure, to monitor their case weights, so they could see what was actually coming out of their plant after everything was being boxed. And they quickly realized that sometimes they overfilled their boxes by quite a bit, and this was, costing them money, obviously. So just by doing some simple things like that, they were able to pull up reports and see that, hey, we've got a problem going on here, and we need to come in and correct that. Now, this report is showing all your OEE numbers kind of rolled up into one high-level view, and this is showing your availability, your performance. Your OEE is the yellow line here, and you can see how kind of OEE is bouncing around between just right around 40%. But I find this interesting because these are hours and this a day's worth of data, and you can see if you look closely that green performance line varies quite a bit. In the morning, they were doing quite well, and they got on a good run, but then in the afternoon, the performance really started dropping off, and that had an impact on the overall OEE number and for that machine for that day. So these are things and trends that you can look at, dive into, why is that happening, and then you can look at, a day or a week or even a month's worth of data over a single line or a machine and start seeing trends and things that you can fix. So if you're not collecting this data and producing these reports, you would never have this kind of insight as to what's happening. And I think this is a real power of OEE and other performance monitoring, is it just gives you that insight. You have these gut feelings, but this really tells you for sure what's happening. All right, so what did they achieve? After putting in their initial system, they immediately saw a $400,000 savings over 5 months, and this had a lot to do with just improving the performance of their machines and also getting a handle around their inventory and their quality because they found that their ingredients were varying quite a bit from batch to batch, and they were able to address that. They also, were able to see those cost impacts for changes that they made, and they were able to tell, if they had the impact, if they actually had the benefit that they thought it would. The real-time reports, allowed them to respond quickly to problems versus, seeing a manual report that was put together, and they'd see that at the end of the week or a monthly report, and now they really can't go back and do anything about it. They can only try to address that going forward. So the real-time reports was huge for them. And then just to reiterate, validating those improvements, that was super important for them, and they were able to start doing that. So, after the initial pilot was done with Rockwell, like I said, we went in with DST and we massively expanded the OEE system to go onto all their equipment, and even expanded into quality reporting and things like that. And we did a huge amount of work, and once they saw the benefit, just doing the simple basic OEE stuff, they realized, there's so much more that they can do, and they started investing a lot of money. And so we still work with them today on, refining and expanding and, continue to do work on the OEE stuff. All right, so just a quick summary, and then we'll get to the Q&A if anybody has anything. But, overall, just remember, OEE is we're just trying to measure that performance gap, the overall equipment performance. And we're just trying to find out what that difference is between the ideal and the actual. And we want to do that continuously so that we can figure out, is a machine running like it should be, day to day for operations, but also for investment purposes. Is it time to add another machine, or is there upgrades that we should do to a specific machine? OEE can really start simple, and I recommend if an organization hasn't done OEE, just start simple. Let's just start collecting some data and see what it looks like, and talk about it, and figure out what you can do with that data to help improve your facility. Monitoring this performance is really critical. If you're not monitoring it, then you're just not going to have that insight to make all these decisions and understand, where you need to invest. I think automating data collection and real-time reporting are also key to this. If you can start off going that direction, it's just the response, the turnaround, this closed loop that you're going to get with your machine running, looking at it, making adjustments. Automated data collection will allow that to happen, and you'll be able to see that data through reporting. Also, it kind of removes the human factor. People tend not to want to report bad news, and they like to overstate good news. So this can kind of give you a better, a more, I guess, factual data that you can trust, and you don't have to have those kinds of worries. So definitely try to automate and get that real-time reporting. And yes, DST is here to help you do all those things if you think that would be a benefit to your organization. I'm going to turn it over to Reed here for a real quick summary about DST Controls. Some of you may not be familiar with us, so we wanted to give you a little bit of background on what we do, and then we can do a little bit of Q&A if we have time. Reed?
All right. Hi, I'm Reed Hayward, Vice President and co-owner of DST Controls. And one thing I wanted to add to Lonnie's summary page on this, and that is that this sort of stuff, OEE, has had different names over the years as far as efficiency is concerned and equipment effectiveness. And OEE is the current one, and it's the most refined one and very useful. But one of the things is, since it's been being done for a while, Rockwell is the first company that's come along with a suite of hardware and software products that actually makes this affordable for the small, medium-sized, or otherwise budget-challenged companies. It's been done for a while, but it's usually with very, very expensive platforms, with very expensive consultation involved, and long time periods, or long schedule periods, implementation periods. Rockwell has really reduced the time necessary to do this, and dramatically reduced the cost by integrating it with their existing control hardware. Okay, so DST's been around since 1975. We've been automating industrial processes since then, so we really know a lot, up close and personal, about where industrial data comes from, how to get it, and what to do with it. We're basically a three-cylinder engine, three-offer company. We're electrical contractor, C10 contractor license, and we have a UL 508 panel shop. We have standard control systems integration, and then our data group, which is the largest part of our engineering group, which Lonnie's been talking about for the last 20 minutes. We have customers nationwide, including Southern California, and our engineers like to travel. And the good news is that more and more of this higher-end industrial Internet of Things data work can be done remotely. So we do a lot of work remotely for our customers all over North America. And that's about it.
Okay, great. Thanks, Reed. All right, I think that, and I'll put up this slide here. This is our contact information if anybody would like to call Reed or me. We're definitely interested in discussing any potential projects or opportunities that might be out there that people are interested in. We're just happy to talk about these things. I think there's a huge amount of value with performance monitoring and grabbing this data off of plant floors. This personally has been something that I've been interested in and doing for over 25 years now, and I've seen the benefits and what it can do within a facility. So if you're not doing it, my question is why not? When are you going to do it, and when's a good time? I mean, this is money, this is opportunities. These are things to really have a big impact on virtually every manufacturing process. So highly encourage for you to think about it and talk to others within your organization and figure out what is a good next step. If you're manually collecting data, getting into those automated collection and real-time reporting can be hugely beneficial, because I know that it can take a lot of time just to collect all that data, and key people are spending time collecting data where I think they would be better served to be able to analyze and figure out, what do we actually need to do. So that's it. And Brian, I know we're a little bit over here, so I guess maybe we could spend a little bit of time for questions, Q&A if people have anything that they want to discuss. We'd be happy to stick around.
Yeah, so let's take at least a few minutes anyway, and did want to open it up, and if anybody has any questions at this point, please feel free to weigh in. All right, so if there's no takers in the short term, I actually have one question I wanted to post to the DST team. And in kind of the course of the presentation, you showed a few screenshots of the reports that are generated by the OEE software. Can you comment just from a general standpoint on who within the organization utilizes those reports, whether that's engineering, operations, management, and how it's really being adopted through the organization? The reason why I ask is I've seen implementations in the past where companies struggle to trust the data in the reports, as well as to kind of regularly utilize the reports to achieve the optimization, and just wanted to get kind of your perspective on how that was addressed.
Sure, that's a great question. Typically, what we've seen is that there is somebody within the organization that's the process improvement champion, and they're charged with implementing these projects and keeping kind of the candle burning with OEE and other types of performance metrics. So they're usually like the primary person that's overlooking the data and the reports and making sure that things are in order and things are making sense. So when other people look at them, it's not going to be there's not going to be some question about the information. So that's like usually a key person within the organization. That usually somebody out of quality or operations that leads that charge. But then from there, as far as using the reports, it really falls into all areas. At Barry Callebaut, the plant manager looks at these reports, probably hundreds of times a day. He's just constantly monitoring his plant, making sure that everything's happening the way it needs to be. And then the folks over in operations are super interested in, ensuring that they're on top of any problems that come up. And then the quality people were very, very concerned about, these batch reporting. Are we actually putting all the ingredients in the proper amounts in everything that we're shipping out? And so they're pulling up data and reports constantly, to make sure that's happening. And so really, I would say across the organization, people are using that data for different reasons, but it's still, it's been hugely valuable for each group.
Okay, I appreciate that. Any other questions? All right, well then I'm going to throw one more out there while I'm at it. So for an organization looking to implement some sort of an OEE solution, whatever that's going to look like for their application, from a best practices perspective, since you've actually done an actual implementation, how would you encourage a company to, what are kind of the first steps to get started? Should they be looking at an entire line? you know, some sort of a pilot project, you know, how do you recommend what that engagement should look like?
Yeah, I think that's a good question, and it depends on, there's usually two different types of organizations that are looking at doing some kind of system like this, and one is an organization that's familiar with lean manufacturing and OEE, and they're manually collecting data. That group typically can start off with maybe a larger implementation because they already have ideas of where they'd like to put OEE in, but usually it's going to be some kind of a critical component of their manufacturing. They know that, hey, when this machine is not working, you know, things are really going bad, and this is where we need to monitor to start with. And so typically, you know, you put in, we'll go in and we'll do a machine or a line, and they can kind of start figuring out how they want to use the software and develop the system and then expand it out to other machines and lines from there. The other type of customer that we see quite a bit are those that haven't done any type of performance monitoring in the past, and so they're really new to it. And with those customers, we like to, you know, sit down and talk about, you know, this 20-minute presentation is just a primer, but there's a lot more that can go into, you know, decisions around what performance monitoring means to an organization. And so starting to have those conversations with them early on, and then tailor a program that really would make sense for them to get started, you know, looking at the machines and the networking and the equipment and figure out, okay, you know, how can we keep the costs as low as possible, but get some kind of meaningful measurements out of your system so you can start using that information, you know, to improve your performance. And so with those, there's a few different programs that we have done with customers. One is what's called the Express Proof of Concept, and that's where it's literally just we're going to set a server up with metrics running on it. We're going to hook it up to a machine, and we're going to give you OEE data for a couple of days, and you can see what that looks like. And that's done with no charge, but it's really more intended to kind of give you an idea of what OEE is and the capabilities of metrics. And it's not going to be a full implementation of even a simple OEE system for anyone, but it certainly is a great way to see if, hey, is this something that I could get buy-in from maybe. Maybe you don't feel like you have the support within your organization, and you just need to show something to somebody to really kind of drive home what this could mean for you. And so that's a great way to go. And the other companies that already kind of know, hey, we really want to do this, then I would recommend, you know, let's get a pilot together, spend a little bit of money. You know, we're talking, you know, less than, you know, probably a few $1,000s to get something in and get some real OEE measurements off of a specific machine and start looking at that real-time reporting and event data and all those other things that we weren't really able to dive into with this presentation. So that's kind of like I think the typical engagements that we're having these days. And so we're definitely open to doing any of those, and you know, every person at you know, a company, it's going to be different case by case. So I don't think there's definitely one size fits all, but there's a lot of different ways that we could go about it.
Excellent. Well, I appreciate that. So since we are running a little bit over at this point, I do want to thank the DST Controls team for presenting, and for everyone that attended. If you'd like to have, to Lonnie's point, if you want to have additional discussions on this or related topics, please feel free to reach out to the DST Controls team or reach out to your CED, Royal Wholesale, or CES sales reps, and we can discuss further. At this point, due to the time, we're just going to go ahead and close out the session, and thanks again all that attended.
Thank you, everybody.
Thank you, everybody.